Hey everybody, here's a problem in Newton's laws. We have a wagon with a mass of 7 kilograms that we're going to propel forward by applying a 10 Newton force at an angle to the direction of motion. We want to calculate the acceleration of the wagon, so we're going to have to find the force in the forward direction. And we do that by resolving this force vector into its horizontal components, f sub x here and f sub y. We're not really going to use f sub y in this problem. We're really just interested in f sub x. So those vectors form a triangle like this, and let me just rewrite that triangle over here so we can make better sense of it. We know what the hypotenuse is. It's our 10 Newton force, and the angle that force makes with the horizontal is 50 degrees. So we have force in the x direction, force in the y direction, and 10 newtons. So then we're just going to apply a little bit of trigonometry. So the force in the y direction is 10 newtons times the sine of that 50 degree angle, and the force in the x direction is 10 newtons times the cosine of the 50 degree angle. And that just comes from using SOHCAHTOA trigonometry. Okay, so let's go ahead and calculate f sub x. That's just 10 times the cosine of 50 degrees. Make sure you have your calculator set in degrees. And so that looks like 6.428 newtons. I'll keep a bunch of digits here while I'm working the problem and then round down later. So now we use Newton's second law. Force is equal to mass times acceleration. And before I plug in any numbers, I'll just rearrange this equation to give acceleration is force over mass. And I can plug in my values. 6.428 newtons divided by a mass of 7 kilograms. And let's just check the units now. A newton is a kilogram meter per second squared. And we divide that by kilograms, so kilograms are going to divide to 1, cancel out, and so we have meters per second squared, which is the unit of acceleration, so we're in good shape. So acceleration then, just doing that calculation, is 0.92 meters per second squared.